episode is brought to you by our members on YouTube and our private community. If you like the show and want to support us to keep the show running, please consider becoming a member or making a small donation using the links in the description of this episode. Hello everybody, I made a video a week ago answering an important question from my followers. Can the new honeybee vaccine against American Foulbrood, a bacterial infection, also help against infectious diseases transmitted by varroa mites? The video generated many other questions that I didn't cover in the video, so I invited today's guest, Dr. Dalial Freitak, assistant professor at Karl Franzen's University of Graz in Austria, where she conducts her research, to talk about this topic. She's the inventor of the vaccine and one of the founders of Dalial Animal Health, the company bringing these interesting new tools for beekeepers to the market. In today's episode, we'll talk about her career and background, the challenges of developing a vaccine for honeybees, what do we know so far, its potential, and its future. And now, I introduce to you Dr. Dalial Freitak. Welcome to the show. Finally, we're making this happen. How are you, my friend?
I am very good. It's a pleasure to be here. I can't believe it has taken so long for us to meet here.
I know, you start to get very famous to be the person behind this famous vaccine for bees. You know, everybody's talking about this new technology. Tell me a little bit about your background. You know, people want to know not about only the scientific background, but, you know, tell me a little bit about you. Where you're growing up, what things do you like to do, and also your scientific background.
Yes, so I am born in Estonia, so I'm Estonian. I grew up in Estonia and in actually very, very little town called Valga, so it's in South Estonia next to the border with Latvia. And relatively early in my life, I decided that I want to become a scientist and that I want to become a biologist. And driving force, believe it or not, the books from Jules Verne, Captain Grant's Children or similar things, but they're all about discovering the unknown. So this really kind of fascinated me to discover something what is not known before or basically map the unknown world. That was really my motivation to become a scientist. And while I was growing up, I realized there are no uncharted places on planet anymore, maybe in the deep sea, but the land masses are more or less charted. But it is kind of a logical step to become a biologist at that moment, because in biology we still have so many questions that are not answered, and we still don't know exactly how everything functions around us and what are the most important things what keep us fit and how can we adapt to changes in the environment. So basically that was my motivation to go into zoology, to understand how are animals adapting to the changing environment, what keeps them alive, and how do they pass this knowledge about changing environment to the next generation. So that's how I became interested in biology and decided to start my studies in Tartu University in Estonia. So I did my bachelor's in Estonia. I started to work with, actually not with honeybees at all. My first model organism was cabbage butterfly called large white. So I remember I was going to the cabbage field and I was collecting a lot of caterpillars and was growing them in my student room to see how they look like. And I entered into the physiology lab where you could build all kind of things yourself. It was absolutely fascinating. And actually, I think from a very first semester, it was clear for me that I want to also do a PhD and continue my academic career. I was kind of determined. And I also did my master's in Estonia in a fantastic group. So my master's is done in animal ecology, and I still work with actually cabbage butterflies. And but that was already a moment when I kind of slipped into immunity, because immune system and defenses against parasites is such a central part of staying alive of any organism. They are kind of the defense mechanisms. If we don't have them, and we need them, it's really bad. From the other side, if we have them and we don't need them, they are really costly for organisms. So I've been fascinated by immune defenses, because how do I know when should I have them and when should I not have them? So that is one of the exciting questions for me during already my master's studies. And then one thing to led to another, and I decided to do my PhD in Germany, and that's when I left Estonia. And I have not returned yet in my academic career, at least.
Okay, so and how you got into bees then?
So bees took a little bit of time. So after I did my PhD and I did my first postdoc, and then I got to my second postdoc, which was in Finland, in the University of Helsinki, the social insect group. I actually started with ants and not with bees. But I met a colleague who was working with honeybees and phytogenin, and we found very fast out that we have a lot of exciting questions what we shared, and passion to understand the function of physiology in honeybees and what's the role of different proteins in immune responses. So that's how I slipped into the honeybees, because honeybees have the best model organism at the moment to answer some of the exciting questions what we had in basic research.
Wow. And okay, now we have a very interesting glimpse about your academic path and how you get into bees and how you get into a vaccine to bees. That's the question everybody's asking me. Where did the idea come from? Can you give us a little overview about the conceptualizing idea? Where do you pick up those things in the air and bring to the lab and make the magic happen?
So let me see. How far back do you want me to go?
Well, we have time. We have
time. So let's start from the beginning. So I need to go back to my PhD time, actually. And that was not when I was working with honeybees yet. But like I said, my question was, how do insects are priming their offspring against diseases? It was kind of a black box at the time. Nobody knew that. It was not even quite sure if encountering bacteria or pathogens in one generation would anyhow translate into the second generation. But there were some observations what showed that, so if mother or father has been exposed to some pathogen, the next generation is more resistant. But we really didn't know what was happening. So that was one of the basically parts of my PhD, to find out what is happening on a physiological level if parental generation grows up in an environment what is infested with bacteria. So what is happening with immunity in the second generation in their children, so to say.
Just for the people at home to follow us, this is what we call transgenerational immunity. When the first generation is exposed to something, the next generation at that time, when you start working with this, there was some data already suggesting that that the second generation of a social organism have some sort of protection, but nobody really knew how. Is that what you're talking about?
Exactly, that's what I'm talking about, and not only social organisms. We're talking about solitary insects, for example. We talk about butterflies, beetles. So that was really where it was kind of like raised in literature and experiments done to understand that what is happening in your systems. Because what makes so maybe again, let's take a step on the side. What makes insects so different compared to vertebrates is that their immunity, very sophisticated. I've heard a lot of people tell me, insects don't have any proper immune responses, or it's very simple, or, they cannot really fight off the disease. This is not true. Insects have extremely complex and very sophisticated immune recognition mechanisms and also response mechanisms. They have plethora of enzymes and proteins and cellular components, and they are all targeting different pathogens and are really, really important in fighting off the infection. So insects can recognize whether it's a viral infection. They respond accordingly. They can recognize bacterial infections. respond accordingly. They can recognize fungal infections and also respond accordingly. They can encapsulate pathogens. Basically, they are forming this capsule around pathogen in their body so that the pathogen cannot infect it or basically live inside the infect anymore. They have fascinating enzymes and proteins that are able to bind themselves to the bacterial surface and basically cut the hole inside of the bacteria. So this is a really cool way to kill the bacteria. So we have those kinds of enzymes, but insects have as well. But now one of the major differences is that insects do not have antibodies. So antibodies are the hallmark of adaptive immunity or immunological memory. And it's only present in vertebrates, birds and mammals and fishes, reptiles. But insects do not have those. And presence of antibodies has always been considered as something prerequisite for being suitable for vaccination programs. So, because our immunological memory is based to a large extent on antibody type mechanism. So basically, once we encounter pathogens, we kind of memorize it, and second time we see it again, we have immune response ready. So basically, our immunity is ready to fight it off. Now, insects don't have those molecules. That's why this phenomenon of transgenerational immunity, that there is something that goes from one generation to another, that's very kind of, it is black box. So what is happening? Some people didn't believe it's happening. It must be a side effect or something similar. Because again, antibodies are not present. And of course, nobody even thought about vaccination. For vaccines, you need antibodies. We know that's what we measure as a response to a vaccine. So that was like going on aside. But I was interested just having a look. So what is happening if the environment is contaminated with a lot of bacteria in the parental generation? How does immunity in the next generation look like? And what I saw was very clear that if the mothers and fathers are exposed to a lot of bacteria, then the immune responses in their children are going up, so to say, in the next generation. They have more enhanced immune responses. They have higher steady-state level of immune molecules. So that was like, So that basically shows, yes, there is somehow some sort of signal is transferred to the next generation. So there is something what is leading to transgenerational immunity. Now the question was still, what is it? How is it done? Because in humans, with antibodies what are transferred, what will give this different immune responses or a higher resistance in next generation. In insects, we don't have them. So that kind of stayed a mystery. And so then I took a step back and I started to think, so how do insects encounter actually pathogens or bacteria? And just looking at my experiments, well, it's actually, bacteria is pretty simple. They are eating them in, so they are encountering the digestive system. So a kind of part of the diet, like, and then we get salmonella, it's oral exposure, right? You relatively fast know that I ate something what was not supposed to be there and my body reacts to it, right? So basically, a lot of bacterial infections, not all of them, but a lot of them also entering via oral route into the organism because they are able to overcome the gut barriers and infect the host. So my question was, so what happens with this bacteria once they are digested, once they are entering the gut? And so that's where I kind of started to think, okay, so can I label those bacteria somehow and trace them? Like, being a scientist, okay, we eat something, where does it finish up later? Maybe it just goes all out, or maybe not. And that was, I think, one of the last experiments I kind of did during my PhD time, because I was almost finished. It didn't even go into my PhD work. I kind of tried to feed my caterpillars at that time with fluorescent bacteria. So they had a little glowing marker on them. And I tried to see, can I actually detect those bacteria somewhere inside of a body of the caterpillar? And I was. So that was my knowledge going out of my PhD. So then I continued to my first postdoc. And of course, I was still fascinated by the question. And I finished up actually in the Department of Applied Entomology at that time. And my next model system was another moth species, and it was a wax moth. And I kind of wanted to continue along the line and see, okay, so I have now this species of bacteria. I can see them in the gut film, and where else can I see them? So are they taken up? So I used the wax moth system, and what I saw was, yes, if I feed the female wax moth, and this is very simple, I mean, they are eating themselves. So in the larval stage, I fed those wax moths with labeled bacteria, and I was able to see those labeled bacteria later in the eggs and in the ovarian system of the wax moth. I was like, it seems that these species of bacteria are actually going through the gut system, or at least in this moth species, and finishing up in the next generation in the eggs. Well, that was it from my first postdoc. So, okay, definitely these species of bacteria are important for transgenerational immune priming potentially, because we already know that the species of bacteria would be in the eggs, they are able to produce immune response in the eggs.
So just go back a little, just to recap here in my mind. So on your first postdoc, you were able to basically kind of paint some bacteria, make them easy to drag, and put in wax moth. And the first finding that you found was that in the female, when she fed, somehow this bacteria is processed by the gut, and this is going to end up in the eggs of the next generation. That was your first postdoc. Wow.
That is my first.
Then the ideas start to come. What do you did next?
Exactly. Then, we always have a very short contract, so I had to move on with my life and with my moving around to Europe. So I finished up in Helsinki in the social insect group. And so I started to do slightly different things at that moment. Like I said, I worked with ants. They are small, a lot of experiments and not so simple with them. And in addition, of course, they are social insects, right? So I moved from a solitary insect, feeding themselves always. There is no social structure. Every individual is an individual, to a world of superorganisms. Fascinating, no? Took me a bit of time to start designing my experiments. I remember this fascinating first meeting with my professor in Helsinki. He said, so I would need at least a sample size of 40 in each treatment. And she's looking at me, I think 40 colonies. How big fragments do you need? I'm like, fragments.
Yeah, you learn fast about honeybee research, how different that is.
I know. I was working in ants, so that was in a way easier a little bit. But then I figured out, okay, the sample size 1 is actually not one individual; it's like hundreds of individuals. But so I had very fast learning curve, so to say, and so I started to also some immunity work in ants. And while I was still wondering how to continue my studies on transgenerational immunity. With the questions what I was really excited about, because tracking fluorescent signals in the small ants and feeding entire colony was very, very difficult. But then what happened is that a new postdoc joined our group in Helsinki. Heli Salmen. And she was working exclusively with phylogeny in honey. And she gave this group presentation like we had every Monday group meeting, and now and then everybody needs to present something, and she talked about the previous work and her PhD and about phylogeny, which is a wonderful protein. Of course, I've heard about phylogeny It's a egg yolk protein and it's important. The source protein does a lot of things. And then she kind of mentioned, among other things, oh, by the way, in fish, we know that vitellogenin can also bind to bacteria. And that was for me this kind of,
Boom.
It was really like, I need to talk to this girl. So after the meeting was over, I asked her to the side. I still remember very well. So our meeting room was on the fourth floor in Helsinki. Fifth floor, doesn't matter. But the sofa in the tea kitchen is red. So we sat down on that red sofa and I asked them, so I had this idea that, I have a signal what is based on pieces of bacteria, what I think is going in maternal organism from one generation to another. And I think that vitellogenin could be the carrier protein. Do you think we could do an experiment together so we could, put my signal and your protein together and see if it works? And she was like, yeah, it's kind of hard to purify it, but I do have a bit in the fridge. How much do you need? I'm like, I have no ideas. How much can you give? And so it's just two of us. We decided the experiment, ordered our first queens. I think it was 20 honeybee queens, and did our in vitro experiment where we had then these two groups of ovaries. We didn't do it on all queen. We just wanted to see if it's really important, if vitellogenin is the carrier of the signal, and then we incubated and part of the ovaries with vitellogenin and labeled bacteria, and the other group with labeled bacteria but without vitellogenin, and then blinded everything properly. And then we imaged later to see if really the uptake of bacteria was dependent on vitellogenin. Very exciting times, It's like I got to, literally touch my first honeybee in the lab, to dissect my first honeybee queen. It felt really funny. And also strange because, a fun fact, the first queen I dissected didn't have ovaries. They were not well developed.
Yep.
And by that time, I already had dissected a lot of moth ovaries. And I thought, this is simple. You just open the abdomen, there's just nothing else but ovaries. And then we're opening this queen and I know it's my first queen, but I can't find ovaries. Where are they? And we just then started that queen, and it's very good. But the other things worked out perfectly. So we carried out the experiment, did the imaging, and we had very clearly two groups. So group A had signal and group B didn't have signal. And once we unblinded, it was very clear that only in the presence of vitellogenin, the immunological signal is carried to the ovaries. So so that was like one of those days, of basically one of those nights I could not sleep because something what I've been thinking for so long. I think I started to first think about it in 2018, and within 13, 14, I was like, yes, it actually works. My theory is correct. This is a mechanism of transgeneration immune priming. I mean, I could not sleep. I remember I was just kind of sitting in my bed and having this huge smile in my face. Oh my God, it's so cool.
That's amazing. Yeah, I can. The feeling might be really good, to have a discover like that, and go not only the discover that you prove a point, but when you go to the mechanistic level, I think it's another level. You know how it works from the molecular level, and that when that happens, you can do lots of things. You can start to tweak things. You can expand the research much easier. It's much different when you have a conceptualized result. Okay, this group have, but I have no idea how it comes from A to B. So you can't do much. The effect exists, but you can't do much. But now you reach a point that you know the mechanism. And from there, what did you do? My first question for you will be what kind of bacteria that those proteins match? Any kind of bacteria, all kind of families of bacteria. How about the good bacteria? That happens the same? Can you elaborate on that a little bit?
Yeah, okay, very good. So what we believe right now, and this is where still so much research to be done. So what we know that mechanistically, that's how immunological signal, at least one type of immunological signal is transferred from one generation to another. With which efficiency different types of bacterial molecules are transferred, that we of course still know. So what we've shown that it can bind both gram-positive bacteria, that would be, for example, American Foulbrood. So some of our binding experiments were done with American Foulbrood fragments, but also gram-negative bacteria. The first in vitro studies done actually with Escherichia coli, because that was commercially available. So that we just could buy. We know it had a good quality of the material, and it's easy to trace. So we know and E. coli is not a pathogen in this sense in honeybees. So it can also transfer the signals what are not necessarily only pathogenic. What we believe right now is that it depends on the concentration of the signal or how much of specific bacterial fragments would be present. Vitellogenin is probably not very selective. There might be some specificity or some binding preference to one type or to the other type of molecule, but this is still very much work in progress. We don't really know too much about it, how it would be. Also, vitellogenin, of course, has some genetic differences between different regions, and it might be that there are some regional differences for a binding as well. But that is something where we need to go still one day. But we believe that it's not selective only for pathogenic entities. So vitellogenin is not to be super sticky protein, literally anything to it, which might be part of its functional immunity. It's probably vitellogenin because it's a storage protein. So who doesn't know this is an egg yolk? So everybody who eats eggs is encountering vitellogenin on a daily basis, basically. So that's the egg yolk protein. Its function is not so much transfer of immunological signals, but really providing nutrition for embryo. And in some cases, it's up to, I think, 92% of the dry weight of the egg is vitellogenin. That's how important it is for developing of the next generation. But yes, it carries also interesting signals from one place to another, among others, than immunity related.
That's fascinating to me because I think I like the hypothesis you have is about quantity, because that makes a lot of sense from the immunology perspective. When you have a gigantic invasion of bacteria and high propagation of that one, they need to cross some threshold, and that's going to be the trigger for the system to start to bind those things and transfer the things to the next generation, so the next generation would not be affected that much. That makes a lot of sense.
Absolutely. That's what I believe is happening. So if there is some pathogen, but if it's present only on a very low levels, let's say there are 2 or 3 bacteria, it's not worth to prime your immunity. Because remember, I'm coming from basic research point of view. And like I said, I've been very curious. So when does it make sense to upregulate immune responses? Because they are costly. Immunity is not for free. It comes on a cost of, in some cases, producing less offspring, or they are smaller. So you really need to know how much and which type of immunity one should invest. So only if a pathogen is present in specific level, when one should do something about it. Because if it's in negligent amounts, then it does not make sense to upregulate all your immunity against it.
Make a lot of sense. Okay, now you got the mechanism, you got the idea. How we move forward to get the vaccine where we are today?
Well, that's when the real work really started, I think. So that has been extremely challenging, but also very fascinating route, I think. So we've, of course, talking about our results to different people, and so it's like, I think most of people were really fascinating about it. So I remember I was running around with my laptop, having this glowing ovary photo on it, and then look what we found, look what we found, look what we found, and some people like, oh yeah, you, like crazy academics. And when we explained what it is, we said, this is totally cool. Girls, you should patent it, and this would be like real world solution. And that's where I think we kind of took the step and thought like, yeah, it actually could be a real world solution, because we're so focused on a basic research and in fundamental science, and on the discovery itself, that was maybe not the first reaction. But after having a few discussions, was like, yeah, well, let's give it a try. Let's see what our innovation services are helping. The university has really good innovation service. What do I think about? Is it worth something? So if you want to commercialize something in university, there are like some really good offices to go and talk to. So we invited them over. We presented our data, and yeah, that's where the journey really started. And we said, yeah, this is cool. We're gonna take it on. Have you published it already? We said, no, we haven't published it yet. Then hold your horses. We're going to hand in the patent application. And so that was done when we published it. And then, of course, it was immediately asked, so would you be interested in trying to commercialize it? Can we build a startup out of it? And yeah, we were like, hell yeah, of course I want to do that. So basically, is somebody going to bring the first bee vaccine on the market? I want to be one of those people. So I want to be part of that team, because obviously nobody can do it alone, but it's kind of, my discovery. I want to be part of it. So that's where it really started. So I managed to get some money for commercialization projects in Finland. And during this phase, we did a lot of pre-work in creating a company.
Cool. So the company started, and how we become Dalial Animal Health.
Yes, so actually the first project was called Prime Bee. So I think
I remember that, and I need to apologize. I don't know if you remember my first video. I was a little harsh on you guys.
Yeah, you actually were, but I was just completely ignoring it. I've had some even harsher reaction.
I thought when you guys released that website, there was a lot of mistakes in the website with bees counts, and so, oh, this is not looking good. I need to do something about it.
Well, you have to think about it. It was our first attempt.
I know.
We were balancing our academic careers and trying to commercialize it, but yes, but it still was growing. So it started as Prime Bee. And during the Prime Bee period, I actually met Annette Kleiser in Helsinki. She was
the CEO of Dalial.
A CEO of Dalial, exactly. And so while I was looking for a business partner, cutting the long story short, I was looking for a business partner with whom we could basically take it to the next step. I happened to encounter Annette and some other people. They did some other function in Helsinki at the time. And I was in innovation services where they were having kind of reviewing some projects for the innovation services and in Helsinki. And the CEO of innovation services says, hey, I have some people here. Would you have some time to pitch your idea? And I was like, oh, I'm not prepared, but okay.
Okay, let's go.
Oh, that is like, I think where I managed to convince Annette that, yeah, this idea is actually pretty neat. So I had I had my Queen cage with me, and some random slides on my laptop. I said, oh yeah, cool, okay, so I envision this, and I have an idea for bee vaccine, and this is how I would think we could do it, and this is how the mechanism looks like, and the rest kind of is a history in a sense that we had a lot of online meetings, and then we had a brainstorming how we would like the company to be called. And so we just decided to combine our first, basically the letters from our first name. So it's
Dalial.
Down from Dalial and A-N from Annette.
Annette, Dalial Animal Health. Okay, now I know.
And we very consciously chose to say animal health and not bee health because...
Although I can see that because this can be to all kind of industries out there, and that can become huge.
Yeah, because for me, from a get-go, it has been a platform technology because it's a platform mechanism. It's has potential to take place in all the egg-laying animals on Earth. So it's not only honeybees, not only in moths, but also in other invertebrates. So that's why we chose consciously animal health, because
the shrimp market would be a good one too.
Absolutely, and shrimps are one of the hopefully targets one day, because vitellogenin is all of them, present in all of them. They are all exposed to diseases, and also third generation immune priming is important for all of those. So from a get-go, for my vision, this technology should be used in all the invertebrates, not only exclusively in the honeybees, but of course honeybees are very important for a start.
Quite interesting, yeah. And also it's amazing story, Daniel. I'm very happy for you, your discovery. You make history. This is gonna be going to the books, and I think it's fun to think about those things. What do you think about yourself being historical researcher?
I'm still finding my way around it. It feels now and then really funny being, oh, did I really do that? Oh yeah, I did actually.
Yeah. You're in the books. That's great.
Oh, absolutely. Now it's
writing books about you.
I think I'm still only kind of realizing it. My everyday life is so busy that it's like, oh yeah, no, that's cool.
But I'm sure this is not over, and the work's still going, and I'm sure it's a preliminary vaccine. There is a lot going on, and that's one of the reasons also I want to bring you here, Dalial, because from the beekeeping community, I got a lot of questions like, it works, it doesn't work, and the world is full of so many scams in the world, and people get so many conspiratorial today that I thought, well, the best way to deal with these things, let me bring Dalial here, and we have a very open discussion about the vaccine itself and the preliminary results, where we are right now, how beekeepers can help, and to get the return on investment that you guys are pursuing to deliver, if it's not delivering already. Because in my view, there is a huge potential. And as a scientist, I know the difficulties. As a beekeeper, I know what the beekeeper is thinking. They want results immediately, right away. They just, if you put in the market, I want return on their investment, and that's it. And sometimes when those technologies coming in very early stages, if we do not go slow and careful, sometimes if you run too fast, you fall. And I don't think we want to make it happen right now in this situation. So my question to you, where are we now with the vaccine, the results? I'm following the literature. There is plenty of literature demonstrating, showing results. What the beekeepers are saying, are you following these things? Can you give a little overview where we are right now, and what the beekeepers need to go to the next step, the next level of testing? How is the testing going? I know you guys are selling. There is a provisional license right now, and then after a little while, you're going to have a full license. Let's go over this conversation a little.
Okay, so there are so many questions.
Yes, I know.
I will start from somewhere and yes. Then let's move forward. So what we have, and you're right. I mean, there are a lot of scams out there. I mean, there are a lot of, how would I say, promises that, oh my God, this will change the world, and then everything will be perfect. Dalial has not gone that route. To be honest, I think Dalial has moved very, very slowly, very carefully in our marketing, in our branding, but also with our development of vaccine. So we have put a lot of effort in a first line showing that the vaccine is safe. I mean, that's, I think, number one thing. Because whatever solution one would bring out, but there are some solutions what may be highly efficient, but if they are also harmful at the same time, then that might not be the best idea to use that. So vaccination would, in our vision, could be used for masses or maybe for all the beehives one day in the world, or there's, depending on the disease they are threatened by, needs to be safe, right? So
Safe.
question.
I like
Safety first. Safety first. I mean, because if we can't guarantee the safety of the product, then we don't have a product. I would say. I mean, that goes the same for the human vaccines. I mean, or a companion animal vaccine. You wouldn't want to vaccinate your dog against something what would be harmful for your dog, right? So here we've been using the same logic, basically. We've been testing a lot of queen bees. So, and trust me, guys, during my academic career, that was one of the questions, are there costs of a vaccine? Because I was predicting costs. I haven't found any. Also, I have to say,
it makes sense, right? I'm gonna think like a beekeeper now in a science combined, because this is something that crossed my mind. Okay, if this piece of bacteria they go to the queen, to the next generation, those bees they're gonna from the second generation they're gonna already have the immune system already a little activated, so it's gonna be consuming things from the immune system, right? And these are going to create environments harsh for development of pathogens. But there is it's supposed to have a little cost on that, energetic cost, or, because otherwise maybe the bees to get rid of diseases just keep the thing running all the time, right? So there is a balance that needs to be achieved there. And that was my thought. So it must have a cost somehow. Did you find any of this? Where we are on that?
That's a very good question. And like I said, when I started the project a long time ago, also working with bees, I was trying to identify the costs. I still try to identify them lately. I have not found any cost. So my prediction would have been also, I don't know, maybe queens live shorter, or there is less food production, or less honey collection, anything really, anything. We've been looking also, maybe they collect from different flowers, maybe they bring in different nectar, different pollen. We have not found any cost so far, which is from one side surprising, very positive, of course, for vaccine development.
Yeah.
What of course I see is it could be that bees, since they are social organisms and they are superorganisms, they probably have a way better buffering capacity for this kind of cost compared to solitary organisms. Because remember, I worked with moths before, and all the moths have it themselves. So we talk about the sample size, or the N, it's the N1. N1 in bees would be thousands of individuals. So it could be that any cost what this could bring is buffered perfectly by the hive, and we don't see it. And it does not ever materialize. So that is highly likely. But the costs are just not paid in this case, because they are social organisms. And why they don't, also one reason maybe why they don't keep the immune system all the time activated. Well, if they don't have a signal coming in, there is no reason to activate immunity, right? So it would otherwise be genetically determined, and this is just not happening. So because our vaccine is also basically working on demand, they are only doing it if we prime them against the disease. That's how the mechanism works in this case. So what we know right now, I'm trying to think what your next question, but so what we have right now is safety, coming back to safety. Yeah, it seems to be completely safe for queen bees. So I vaccinated personally about 1,000 queens, I would think, during my in different countries, different circumstances, with different formulations of vaccines, with different concentration of vaccines. I tested different types of vaccines against fungal, against bacterial, against mixed vaccines. I haven't seen any negative effects on queens. They all survived, and they also started to lay eggs. So
And I have to share that I'm also following some people that are using and asking them via phone calls, and I didn't get a single person today that tell me that the queens are weird somehow. So I think I can assure that also there are some beekeepers out there testing it, and I was very harsh on them. Nothing different. And they're queen breeders, so they know queens very well, and they feel that no, I didn't see anything different with these queens. So the safety level, they're pretty fine. That's good.
I'm really glad to hear that also, that you have a good reaction to that. So that's also what I've been hearing so far, that where I had seen, doesn't seem to be anything what would be odd, or what wouldn't add up, or what would be significantly different from non-vaccinated queens. And that, of course, makes me extremely happy. But the safety, like I said, safety is one of the most important parts. And then, of course, the next question is, does it help against the diseases? Or like the two parts of vaccination approach. Is it safe? Does it work? And yes, it works. So our proof of concept studies, but of course are done under highly controlled conditions in a lab, show that it helps against disease in single case. When the queens are vaccinated, the next generation is able to fight off the diseases better than non-vaccinated group. Now, we have not carried out a huge field study where we would have infected the hives against American Foulbrood, because that's also not allowed.
That's illegal, yeah.
That's illegal. So like I said, I would lose all my jobs and probably put in a jail. So I'm not going to do that. So that's not something we can carry out. Also, of course, the field studies are something what are not so simple to carry out in a use level. We have so many confounding factors coming into play, and we're not, again, dealing with a single organism. There are several thousands of individuals who all behave differently and bring something and affect the fitness of the hive. So that would be extremely complex study, which is almost impossible to control. But what we have done in the lab confirms that, yes, the vaccination helps against disease.
Yeah, I saw the paper. I have a couple of videos on my channel about it. I'm very curious about where these things are going. But one thing is always crossed my mind. A video that I released a couple of days ago is about cross protection, because I receive a lot of questions about how this can help. And they say, Umberto, don't get me wrong, but I don't care much about American Foulbrood. But can the vaccine help against something else? And they always talk, can help about against rural mites. So, and then when I start to think about it, well, it might. And that's what I also want to discuss here with you. Cross protection. Because Varroa transmits viruses and diseases. And if the immune system is activated, and the immune system of honeybees is different than us, and is an innate immune system, the same situation of one trigger, they have this potential to help with other ones. Do they? I think so.
Yes, so we have some data on that. So I've been also presenting it in many cases already. So we show that there is some cross-protection also against European Foulbrood, if they are vaccinated against American Foulbrood. So these are both, of course, bacterium. But what it shows to me, there is some potential indeed to have also protection, or like we say, cross-protection against the other diseases. It's not unknown phenomenon for immune system that if you vaccinate or activate the immunity against one pathogen, there's also kind of spillover effect.
Yes.
You have also higher protection against other infections. So this is something, of course, we need to investigate further, and we are doing monitoring in the field. So how vaccinated hives doing? Is there any potential for what can we see already something in the field? Is there potential that the vaccinated hives would have less diseases, less other type of diseases as well? So that is something we are monitoring very closely, because I think there is a huge cross-protection potential.
That's fascinating because I work in the field for a little while with the royal jelly and viruses specifically. Apparently with viruses, we might have a completely different way for transgenerational immunity where the RNA is encapsulated and put in a royal jelly. That's the paper that I published with Dr. Eyal already a while ago. And in your case, the pieces of the bacteria is going to the fat bodies, from the fat bodies to the eggs, and then it stops themselves over there. My question to you is, I'm trying to talk to you and the beekeepers at home at the same time. Because I received those comments and I try to explain those concepts to them, but sometimes I don't have too much time. But today I wanna go slow. Correct me if I'm wrong, Dalial, is yes, there is potential for cross-protection from these specific bacterial vaccine that you're working on against American Foulbrood. You have some data with European Foulbrood, and maybe in the future we might have other data. I'll be fascinated to see some viral work on that. Maybe to see some results with other pathogens there. That'll be great because that would tell us that yes, this same vaccine can help against varroa mite indirectly, fighting the viruses that varroa mite transmit. I'll be watching you very closely on
Very good.
other groups. I'll be to see if something's gonna come up with that. But people at home need to understand also is that you guys might be developing other vaccines too for other things. It doesn't need to be specific this one, but I'm sure other things gonna come up soon. Right? Am I wrong?
No, you're not wrong.
Any company need a second product and a third product. That's the way startups work.
Oh, absolutely. So we have things in the pipeline. Obviously, I don't want to share too much light on that yet before we are further. But obviously, we have other products in the pipeline. And like I said, it was very, very decided decision to say animal health. And also, we are not seeing ourselves as only AFP vaccine company. So this is the first product. Sure, we brought something on the market but did not exist before. We have a regulated insect vaccine. Nothing like that has been out there before. So now when we basically know how to do it, we are developing, of course, our products as well against the other diseases in bee industry.
Fantastic. Regarding still on cross protection, does any other results out there that's able to share regarding other organisms that show cross protection in some regard? Because as a scientist, for me, I'm almost certain that cross protection exists on this. Knowing the immune system of the honeybees the way I know, I want to say for sure, but as a scientist, I need to see the data first. But if I need to put my money in, I like to talk about that to the beekeepers. If I need to put my money in, I will put my money that the vaccine is going to help with other things. And it's just a matter of time to find what it is. There is any other data or something that you can share or something that's out there that I don't know about it? Because I know the European Foulbrood, and I'm sure you guys are working on other things. Are the beekeepers saying anything that they found something when they're vaccinating their queens? Anything?
I think what I can share, what I know that it seems that our hive, the vaccinated hive, this is what our feedback we've been getting from beekeepers, that we haven't really seen any diseases in our vaccinated hives so far. Obviously also not the American Foulbrood. So that is a very positive feedback, what we've been getting so far. What also seems to be that the hives are a little bit, and this is hard to put a number or exact description to it, they seem to be a little bit fitter, more vigorous maybe, more homogenic as a hive. So this is a feeling we are getting. So we had a little experiment running in Graz this winter, not with AFP vaccine, but also vaccination approach. And the surprising thing was indeed that now I'm talking about my academic life, is that though we had really a lot of varroa in hive, and my beekeeper said, oh, they're not going to overwinter. They all overwintered successfully. So we were kind of surprised.
I am hoping so much for something related with that, because we're overthinking a lot of the resources in the beekeeping.
Absolutely. So there was varroa, and so we did treatment against varroa, but you know it probably better than I do how hard it is to deal with varroa infestation in hives, and whatever you do, they just stay there. But the positive was indeed that they all survived, our great surprise, and of course we were very happy to see that despite the high varroa loads, we had really successful overwintering.
Yeah, since that you mentioned that, I also, when I talked with the beekeepers that were testing, they mentioned that they didn't see too much variability too. That's something they realized on the vaccinated bees. The hives were not all over the place like other yards. That's something to explore, that for sure. It could potentially be an explanation that if it's helping with other things, it would eliminate some of that variability that we find in many apiaries.
So exactly. So what I think right now, based on the knowledge we have and observations we've made, and here, big shout out to all the beekeepers who've been working with us and who are using vaccine, testing vaccine. Really thankful for you all guys. Is that we actually have now ability to have this large scale observations and feedback on how it really works, because laboratory studies are super important, but we really only see how it's going to work, which kind of impact it has on the industry once it's out there and while it's being used by beekeepers. Because, I can work in my apiary with 60 hives. That's all I can do. But now we have access to way bigger data sets, and so far, yes, what we hear is very encouraging. And so what I think that thanks to this innate immunity, what is boosted in the next generation, what probably is happening, that they have is kind of a potential to some extent blanket defense also against other diseases, and they are just generally teacher. It doesn't mean that no outbreak could happen, of course. Outbreaks can always happen. But it depends also on the level of infection. So, of course, if you have suddenly you bring into your apiary extremely diseased hive with high levels of infectious materials, there might be issues, obviously.
Yeah.
Or if your bees get heavily poisoned by something, from some pesticide in the environment, or they have absolutely nothing to eat. But then, of course, we are not talking about vaccine effects anymore. When we are talking about nutritional deficiencies or poisoning. And that's, of course, where I would say that vaccine, of course, is not magical bullet what would defend against toxins that it cannot do. So if there's heavy pesticide load in environment, then it can still have impact on the health of the hive.
Yeah, that's my message to the beekeepers right now. You need to give a shot. Give a shot with the bunch of hives. See how you feel, because there is potential there, and you can share. It can be part of this discovery phase right now too, because I don't think we have the full knowledge of the whole potential of the vaccine yet. I'm very hopeful, yes, and it's skeptical where I'm supposed to be, because we need to move by results. Commercial beekeepers especially want to just, when you're running an operation, it's all about what you get in return. And sometimes maybe you don't see it right away. And not because it doesn't work. I would say to them, like, wait, bees and the variability of bees, this is just a starting point. Don't close the door to the vaccine just yet. Give it a shot a little bit more. And very likely you're going to see things that you didn't see in the past. That's my gut feeling right now, where I'm going with the data and the conversations that I have. So my advice to people, give it a try. I think there is a lot of hope on that part.
I could not agree more. Absolutely, of course. I mean, I think we really have here something what potentially could be a game changer for the industry.
Yeah.
So it has potential to change healthcare for honeybees, because we actually have a regulated product by the government, which we know is safe, which we can use in order to prevent diseases, and it's tested in the lab. And trust me, I'm scientist. I'm my own biggest critic, so I'm trained to poke holes in my own data. That's basically what I get paid for. So I have a data set. The question is, how can I find the flaw in there? These are something we didn't think about. So obviously we are repeating the experiment, especially for something like that, what is not just one publication and let's forget about it. No, obviously there's a very vigorous testing and making sure we know what we are talking about. The mechanism is solid. It works. We know it. It is safe. It has lab efficacy. Now we really need to see how it's going to perform in the field.
Yes, and how can we tweak in the field? And that's the part that I want to help, because I have a lot of experience with the field and all the variations we have there. And I do it, and I know the beekeepers sometimes are very harsh with okay, I'm moving on. And I said, hold on this one. Maybe we should just, there is more in this, sir. And we just need to be patient.
Well, we also need to know what our expectations are, right?
Yeah.
What do we expect from something like that? So what do we want to see, and what this product or approach has been designed to achieve?
Yeah.
And in this case, what we want to see is that we have higher resistance to diseases, or in this case, specifically American Foulbrood, but potential we've also against maybe European Foulbrood, hopefully viral diseases, which all still need shown, of course.
It's going to translate in less variability in the bee yard, and very likely more honey production and more bees. But this it's a neat time for the beekeeper to see. It's not something you're going to put and you're going to see next month.
No.
That's that they need to understand.
No, exactly. And beekeepers also know it, I'm sure very well. There's such a huge impact from environment, and with weather, I mean, like you can lose your hives because it was too cold or too hot.
And just need one plant, specific species of a plant in your neighbor, and your hive is not gonna develop as well as your neighbor right there that didn't have access to the same plant. And beekeepers know that, but sometimes they don't have much patience, or cannot have their patience because their survivability is on the line, and people get desperate.
I absolutely understand it, and it can be very, very, very precarious situation, because we've been having it with our university hives. It's just, somebody sprays something in the private gardens. We have very little control over it, and our bees are poisoned. What can we do?
Yeah. Poison, yeah. This is one of my main concerns right now is the pesticide industry that nobody talks about. It's a problem. Well, I would leave that for another video.
Yes.
When I'm gonna invite Monsanto here. See if they... that was a pleasure. Do you have any other message to the beekeepers out there and the people listening to the podcast? Any news, anything that's coming, or something exciting, anything?
So what could I say? I mean, keep your eyes open. Like I said, we are running more tests and more data, and we are publishing and sharing it with bigger audience as we are able. But I think we should be having some exciting news coming soon enough. We are working on further products, of course, and of course I would like to say big thanks to everybody. It's brave and joining the beekeepers who are willing to vaccinate their hives and really be in the forefront of the animal health industry, pioneers in the sector who are not afraid to try something new out. Every new product, every new invention has difficulties, we know that, but I'm especially thankful to everybody who said, yeah, I'm going to give it a try.
That's very courageous from them, and I think I appreciate them too. To put new technology in the market, it's a long time, very costly, and we need that kind of people with the vision that they want to help, because it's a new thing. There is no much to. Where is my neighbor? Somebody tested. Oh, I'm the first one. You need to have the guts.
Oh, absolutely, and it's been, I'm still sometimes need to tell people, why do we need a bee vaccine? I don't think I need to tell beekeepers why we would need something what helps bees against the diseases and is safe at the same time, compatible with ecological beekeeping. So I don't think I need to preach there. Of course, solutions are needed, but sometimes I'm still encountering people.
That's viable, yeah. It's organic. It's going to be compatible with organic beekeeping. That's true.
Exactly. And so you don't need to think too much about that. And so thanks for being innovators with us. So you are definitely kind of a part of our family, I would say, our extended Dalial family, who is in a forefront making the history literally.
Part of history, yes. You guys at home trying out right now, you are part of history, and you should be proud of yourself, especially when you see this in the future. If it goes where I think it's going, if we're going to look back and say, yeah, I was part of that. That's what I'm thinking right now when I try to do this work. All right, Dalial, that was a pleasure. My friend, is good finally that you were here. I want to thank you for your time, for your great work, and to bring this new technology and new information to all of us with the efforts of your team and yourself. So in the name of Inside the Hive.tv community, thank you very much.
Thank you so much for having me.
All right. And you guys at home, I will see you guys in the next video. Inside the Hive.tv, the show about bees. See you later. Bye-bye.